In this video, we're going to study about the applications of the definite integral, and one of the most important application of the definite integral, finding the area under the curve. We are going to start with that one. From the previous lessons, you know that how to find the area of the curve, how to find the area between the curve and the x-axis. We know by using the integral formula, we know that one. And here, if we are looking for the area, and if the area is below the x-axis, the integral result is going to be negative. That's why we should put minus sign to make the area positive, because area is positive value it's going to be. If you are looking for the area and the sum of a plus b plus c, it's going to be, but here the integrals, it's going to be a to b, this is positive, b to c, it should be negative, because b to c integral, since it is below the x-axis, going to be negative. B to c is going to be negative. That's why it should be negative and negative and negative. It's going to be, as an area, it's going to be positive. And here, c to 2, again, positive, it's going to be. If you are calculating here, the important part here, this is, if you are calculating the area between the function fy and the axis, here y-axis, we should get the function in terms of y. We should write the function in terms of y. Then we should define the boundaries on the y-axis. And what we are doing as an integral, same operations we are going to do. Here, area between two curves, it is given. If the area we are trying to calculate between two curves, fx and gx functions, the formula for that one, fx minus gx, it's going to be. Here, it's same, the formula is not changing. Here also it's not the same, which function is above, which function is below. We should check that one, above minus below, it should be. Here, the functions sometimes above, sometimes below. In area A, the red one, fx is above, gx is below, so it should be fx minus gx, as you see here also. Here it should be equal to fx minus gx, because fx is above. Here gx minus fx it should be, because gx is above. Here fx is above and gx is below the area, so fx minus gx, again it's going to be, as you see, from a to b, fx minus gx minus fx in b to c interval, and from c to d, fx minus gx, again it's going to be. Okay, if we start to solve the areas, here this exercise I have chosen consciously to find the area between them. Already we found and we know how to calculate that one, but this area is trapezoid, so I'm going to find the trapezoid's area also. Here, firstly, this is the graph of x plus 1, and x plus 1 means when the x is equal to 2, y is equal to, it must be equal to 3, and when the x is equal to 4, y it must be equal to, here it's going to be equal to 5. So the length here from this point to this point, it's going to be equal to 5, and from this point to this point, it's going to be equal to 3. And from 2 to 4, we have 2 units, and if I draw the trapezoid here, the right trapezoid, the upper part, it's going to be 3. We are calling the here base, lower base, it's going to be equal to 5, and the height is equal to 2, and the area of trapezoid is going to be a plus c. This is a, this is c, and this is h. By the way, this is a, this is c, and this is h. A plus c over 2 times h it's going to be, which is equal to 3 plus 5 times, over 2 times, it's going to be equal to 2, this 2 and this 2. If we simplify, 3 plus 5, the area is going to be equal to, area is equal to 8. By using the trapezoid properties, I can find this one. So this area is equal to 8. I can find it by using the trapezoid rules. Again, I'm repeating sentence. Here, integral of it, what is integral 2 to 4? The function above the area is x plus 1. So it's going to be x plus 1 dx. Then the integral of x is equal to x squared over 2. Integral of 1 is equal to x from 2 to 4. That's going to be equal to 4 squared over 2 plus 4 minus 2 squared over 2 plus 2 it's going to be, which is equal to 4 squared is 16 over 2, 8 plus 4 minus 2 squared is equal to 4 over 2, it's equal to 2, minus and minus 2, it's going to be equal to minus 2. Here again, 8 plus 4, it's equal to 12, and 12 minus 4, it's going to be equal to 8. So the integral 2 to 4 x plus 1 dx, which is at the same time area below the x plus 1 and between x-axis, is going to be equal to 8. Okay, if we find the area between 3x plus 1 and from 1 to 3, we should write only 1 to 3. Area is equal to minus 3x plus 1 till 1 to 3. 3x plus 1. The integral of minus 3x is equal to minus 3x squared over 2. Integral of 1, it's going to be equal to x. So from 1 to 3, it's going to be, if we replace the boundaries here, it's going to be minus 3 times 3 squared over 2 plus 3 and minus 3 times 1 squared over 2, 3 and here plus 1 it's going to be, and here it's going to be equal to minus 3 times 3 squared is equal to minus 27 over 2, minus 27 over 2 plus, because this is going to be 3 over, actually firstly plus 3 and plus 3 over 2 it's going to be, and this one it's going to be minus 1. Then the answer is equal to minus 27 over 3 plus 3 over 4, 2, it's equal to minus 24 over 2 plus 3 minus 1, it's equal to 2 it's going to be, and here it's going to be equal to minus 12 plus 12 over 12 plus, because minus 27 over 2 plus 3 over 2 is equal to minus 24 over 2, which is equal to minus 12. 3 minus 1 is equal to 2, and minus 12 plus 2 is equal to minus 10. It's going to be, this is the integral value, but the area it's going to be equal to minus 10 in absolute value, which is equal to 10 unit square. It's going to be. The next question. Here the area between the finite graph 1 minus x squared and the x-axis. Firstly, I have to draw the how the graph is going to be. Now we are going to solve what is the area between the finite region between the graph of y is equal to 1 minus x squared and the x-axis. Firstly, I need to draw the graph here. And if you remember, the x squared graph, it's upward, and the minus x squared graph, it was downward. If it is 1 minus x squared plus 1, this is also minus x squared plus 1. Minus x squared plus 1, it means that it is 1 unit up it's going to be. And my aim to find the, and here this is x-axis and this is y-axis, to find the values here. Firstly, I have to find the boundaries here. What are the boundaries? Because they are not known now. And here these are the x1 and x2. We know that one. x1 and x2 means y is equal to, x1 and x2 means y is equal to 0, because these are the zeros of the function. And here y is equal to 0. I wanted to write y is equal to 0, it must be. So when y is equal to 0, it means that 1 minus x squared is equal to 0, minus x squared is equal to minus 1, x squared is equal to 1 it's going to be, and x is equal to plus minus 1, which means here the x value is equal to minus 1, the first value is equal to minus 1, the second value is going to be equal to 1. And the area between them, between these 2 points, is going to be equal to 1 minus x squared, because the above function here, it's equal to 1 minus x squared. 1 minus x squared, the x it must be. The integral of 1 is equal to x, integral of x squared is equal to minus x cube over 3, from minus 1 to 1 it's going to be. Then it's equal to 1 minus 1 cube over 3 minus 1 minus minus 1 minus 1 cube over 3. It's going to be 1 minus 1 over 3 minus 1, it's going to be here, I forgot. Then this is going to be plus, and minus 1 to the power of 3, it's going to be equal to minus 1. Minus and minus, it's going to be plus 1. One more minus we have here, 5 times minus, that makes it's equal to 1 over 3 again. And the sum of 1 and 1, it's equal to 2. Minus 1 over 3 minus 1 over 3 is equal to 2 over 3. 3 times 2 is equal to 6, minus 2 is equal to 4. 4 over 3 is the answer of this area. So area is equal to 4 over 3 is going to be.